So you may think, why we are learning about soap and detergents? We know very well soaps and detergent also organic compound. It contains carbon in it. By now we know that carbon is a versatile element, right? It is present in every substance what we use, whether it is drugs, dyes, cosmetics, even soaps, detergents, and even that is like tincture iodine. So from killing the germs to cleaning the dirt from our clothes and from the body, the carbon is useful. So let us learn about soaps and detergents. So what are soaps and detergents? Soaps and detergents are nothing but substances which will help in removing grease and dirt from the fabric or from the body. Okay, or from body. Okay, removing dirt or grease from the fabric or from body. It is called soaps, right? Soaps and detergents. So in what way soaps and detergents are different? So we know very well soaps and detergent. Commonly we can say, both we can say soaps and detergents as a cleansing agent. So these are the cleansing agents. So they clean. So both help in clean. Both are cleansing agent. But in what way both they are different? So let us say these soaps and detergents are different from each other because of their chemical composition. Okay, because of their chemical composition. So let us learn what is soap and what is detergent. Okay. Soaps are, you know very well, they are made up of vegetable oil. They have vegetable oil, whereas detergents are made up of synthetic substance. That is, they are chemical substance. You don't find any vegetable oil in the making of detergents. Okay. So, and why detergents is preferred by everyone is that detergents will work very well even in hard water. We know that there are two types of water. One is soft water, other one is hard water. The soft water soap will work well with soft water. Soft water means what? It will not contain the salt, right? You know that calcium and salt and the chloride salt. Okay, so those salts will make the water hard. And that soap will not, soap will give very good, soap will clean the vessels, everything very well only in soft water. But we know in most of the locality, whatever water we get, it is not soft water. Usually it is hard water. So soap will not work well with hard water. Only the detergents will work very well with hard water. That's why detergents are preferred. So what is soap? So soap is different from detergent because of their chemical composition. Soap, it contains the oil. Okay, so it contains the vegetable oil. Whereas detergents, it is made of chemical and it is very, very effective in removing the dirt even in the hard water. Even when we use the hard water, it will help in removing the dirt. So let us see how it works. Okay, so how the dirt is removed. So how the soap will work. So soap, what is soap? Soap is a long chain of fatty acids with, or you can say hydrocarbon, long chain of hydrocarbon with carboxyl terminal. You know what is carboxyl terminal? This is carboxyl terminal to which sodium or potassium is attached. To which sodium or potassium attached. So what does it say? Soap is a long chain of hydrocarbon, or it is a fatty acid. Okay, so long chain of hydrocarbon. I'm not writing H. It is understood when it is mentioned like this. It is understood. You have to attach hydrogen. Okay, all this are hydrogen. So you can write this hydrogen. So when it comes to the terminal end, okay, when it comes to the terminal end, we know it should be the carboxyl terminal. So this carboxyl terminal, sodium or potassium will be attached. So what is soap? So it is a salts of fatty acid. It's a salt of fatty acid to which sodium or potassium is attached. Okay, so that is soap. Now, when we look at the structure of this fatty acid, right, hydrocarbon is a very long chain. Okay, so you can write like this. That is CH3, okay, or H3C, H3C, CH2, then again CH2, 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 like this. This will be the structure. It goes on, okay, with the carboxylic terminal. So every time when we want to write the structure of this fatty acid, we can't write very precise structure. Instead, we represent the soap molecule. We represent the soap molecule by this structure. What is the structure? This structure is used to represent the soap molecule. This is the tail region. This is the tail region. This tail region represents the hydrocarbon part. Hydrocarbon part. Okay. And this is the head region. The circular end is referred as the head region. The head region represents the carboxyl terminal. It represents the carboxyl terminal with sodium or potassium attached to it. Either sodium or potassium will be attached. So this is the structure which is used to represent a soap molecule. A tail end. This tail end is called non-polar end. The tail end is called non-polar end. And the head region is called polar end. Okay. Okay, this is the soap molecule. What does this represent? We represented the hydrocarbon chain, right? This hydrocarbon chain is this part, the tail part. Okay, this is the tail part. What is the tail part? The tail part represents the hydrocarbon part or the fatty acid part. Okay, so this is the tail part, and this is the hydrocarbon part. This is the head part. Okay, this head part represents what? It represents the carboxyl terminal. It represents the carboxyl terminal. Okay, which will be attached either with sodium or potassium. Okay, or sodium or potassium attached. This head part is called hydrophilic end. hydrophilic end, and the tail part is called hydrophobic end. Okay, the tail part is hydrophobic, the head part is hydrophilic end. What is this hydrophilic? Hydra, you know, hydra means what? It is water. Okay, so philus means love. Hydra, you know very well here. Hydra is the water part. Phobia means what? Fear. Phobia is fear. Okay, right? So the head part is called hydrophilic end, and the tail part is called hydrophobic end. And this will, as it likes or it, it is attracted towards water. So this will be attracted towards water. So this will be the polar end. This will be the polar end. Okay, and this will be the non-polar end. The tail part is non-polar end, which will be attracted. This will be attracted to oil, grease, the dirt, everything. Okay. The polar part will be attracted to water. Now let us see how it see the cleansing action of soaps and detergents. You know very well soaps. The general formula of soap will be RCOONA or RCOOK. This is the general formula for soap. Okay. And when we talk about detergent, it will be salts of sulfate. Okay. So that is, anyway, that's not required. Now we just learn this. This is the general formula for soap. Okay. So now, how it acts? How it will help in removing the dirt. So before that, let us see how our clothes become dirty. So due to perspiration, you know, the sebum and we sweat, everything. So due to that, the dust particle will collect, which are dispersed in the atmosphere, that will get collected and becomes dirty. So that I told you, when we sweat, that sweat along with sebum, the oil, right? So it will become dirty. So when we use soap or detergent, what will happen? In soap, it will either get disassociated like this. It will get disassociated into this carboxyl and the sodium ion or potassium ion. Then how it acts? So let us see. The molecules of soaps and detergents form cluster of molecules in which hydrophobic part is interior. See, this is the hydrophobic part, right? So this is the hydrophobic part, and the hydrophilic part will be outside. Okay, it will be facing the surface of water. What did I tell you? When we wash the clothes with the help of soap, the soap will break into carboxyl group as well as the sodium ion. It forms the cations, you know very well. Okay, the alkyl group and the ion group, that is cation group, will be formed. Now, when these soap molecules, they will form a cluster. This cluster is known as micellar formation, or it is called micelle. So what is micelle or micellar formation? So let us see what is this micellar. So if this is oil, okay, and we know this is the hydrophobic part and this will be the hydrophilic part. Okay. So this tail is hydrophilic part, hydrophobic part. Hydrophobic part is our hydrocarbon part, okay, and this is the ionic part. The head part is ionic part, and the that is the hydrophilic part. Hydrophilic part, or we say the polar end. The polar end. Okay. Right. So how it is arranged, you see, the hydrophobic part which is attracted to oil. That is the non-polar part, right? Okay, it will be attracted to oil and it is faced interior. Whereas the non-polar part or the ionic part, it is facing the surface of water, and together it forms, like it is not one molecule, it forms several cluster of molecule, and this cluster of molecule is called micellar formation. Micellar formation, or we call it micelles. We call it micelle. Okay, micelle formation. So how will it act? How will it help in removing the waste? Now imagine this is the fabric. This is the fabric. On that fabric, this oil dirt part is there. Okay, and these will form several molecules. The micelles will form, and this is the non-polar end, that is hydrophobic part, and this is the hydrophilic part. Okay. So this is the hydrophobic part. The pink what I have drawn is hydrophobic part, and this one is hydrophilic part. So what will happen? They all will come and they form the cluster, they form a group, and they surround the dirt. They surround the dirt, and they, if this is the oil, okay, so this is the oil, so they will surround the oil like a cluster, and they will get attached to it. They will be attached to it. Okay, and how, I mean, this is just to make you understand how it helps in removing the dirt. Okay, so this is the fiber and it has become dirt or the grease. Okay, and we have used soap. So the soap or the detergent. If it is soap, it will form the carboxylate ion. Okay, and sodium ion will be formed. And next, if it is detergent, it will form sulfonate plus sodium ion. And this you know very well, this is hydrophilic end, because it will be facing the surface of water, and this will be the hydrophobic end which will be facing towards the dirt. Okay, right? And see how it will help in removing the dirt. So when soap is used or detergent is used, they form the micelles. Okay, they form a cluster of micelles, and they help in removing the dirt as they come. Like they just help in making the emulsion. Okay, stable emulsion is formed. Okay, they form a stable emulsion. Both soap and detergent forms a stable emulsion of the dirt and that will help in removing emulsion, you know very well, right? So it will act like a suspension, so that will help in removing the waste, or removing the dirt from our clothes. Okay, so this is just a representation how it will be acting. So several micelles will be formed, so they will help in removing that oil particle. See how it is, like as it is magnetic like that, so it is taking it, and the soap and detergent acts like a bridge between the dirt and the water. Thereby they form a stable emulsion that will help in removing the waste. So that's about the how soap and detergent works. Okay, so you should learn about the micellar formation also. With that, I have completed